Well, welcome everybody. I am sitting in for Prudence today, and I'm happy to do so. One of the things that I'll say, and it's really well timed because I listened to the podcast yesterday, Zach, and where I described something that is just so true, and it happened again yesterday. And it's something I'm always so excited about with the Pass House community, and it's definitely happening on the Accelerator, and it happens just all the time. We're in an industry where people don't like to share. We're in a world where people don't like to share, where you spend years, years and money and time and effort, like honing your craft, and it's like your craft. But the Pass House community, we share, we openly share. And I'll use last night's run through as a great example. It was no different from a lot of the other run throughs where the presenter, which I'll introduce in a second, is asking us, well, am I sharing well? Am I sharing enough? Is it clear? Can people take stuff away from what I'm showing? The community shares all of their details and images and puts themselves like way out there. A lot of the people, including the Natalie, who'll be presenting in a second, they're just way ahead of the curve. And so is everybody on the show, and a whole bunch of people aren't, and it's all mixed. And so you're ahead of the curve, you're putting yourself out there, and then we voluntarily spend an hour kind of picking apart stuff, mentioning all the cool new things you could do. Well, what about that? And what about this? And even the person who presented, who's kind of teaching us all of this great stuff, winds up learning. And I will say it's why I find the happy hour so addictive. It's why I always love the conferences, and it's a lot of fun. So I figured I'd rehash that piece of the podcast tonight and say thanks everyone for a bunch of good 2 years, and to you and Monty, Sean, for bringing this to us. So this has been good.
So we're going to move into breakout rooms now. We'll do 5 minutes, maybe 6 if you're lucky, of breakout rooms. Here, let me set them up. And this is rapid fire introductions. Make sure that everybody gets a chance to say hello. And we'll see you in a few. Well, it looks like everybody's back from the breakout rooms. Thank you. I hope those were fun. I'm going to do some quick announcements here. So let me move to those. So I'm going to do 2 things. One, I'm going to show you the weekend preview. So every week we produce one of these, publish it in the articles on the website, and Pass House Weekend Preview. A couple of things I want to highlight. One is that our current episode 47 of the Pass House podcast is an interview that I had the pleasure of conducting with Chris Ballard, CEO of Pass House Canada. And as many on this call know, British Columbia, Vancouver, and increasingly Toronto, Ontario, even the federal government in Canada are really taking a leadership role in Passive House, at least relatively speaking. And so it's really exciting to see that happen and understand how it's happened, and also see where things are in terms of the role that a key Passive House institution plays once policies are already in place. So they're like 5 or maybe more years further ahead than many of us in the US. So it's cool insights around that. All right, save the dates. This is another thing I wanted to share. So we've got the International Passive House Conference, the Tower Retrofit Symposium by Passive House Canada, FIASCon, and the South Pacific Passive House Conference, all coming up this fall. So lots of really great stuff that you can access from anywhere in the world now, because these are either online or hybrid conferences. So check that out. On socials, we have the new Gravity Accelerated Edition kickoff party that's happening at BS Fridays, which is co-hosted by Mark Willey. So please join that social event on Friday, and I'll be talking more about the new Gravity Accelerated Edition event that will happen next week. I'll talk more about that later. Okay, so the one other thing I wanted to show was that we've got a bunch of bonus episodes of the Passive House podcast. These are interviews that I conducted at the North American Passive House Network's conference in New York City in June of in June. And there are 18 interviews. We've published 3. So far we're doing 1 a day. And Edie Dillman, I know you're on the call today. Your interview just got published today. So really fun, short conversations with some fascinating folks, leaders, practitioners, folks who are fairly new to Passive House. It was fun to produce these. So that's it.
So a bunch of you will remember Natalie from when she presented back in March. It was great. And just a quick intro for those of you who don't know her. Natalie Leonard is the founding partner at Passive Design Solutions. She's the first certified Passive House consultant and certified Passive House builder in Canada. Her mission is to make sustainable, high-performance homes affordable to everyone. She leads the Passive House Design Solutions team with a depth of experience in creating cost-effective, beautiful, and ultra-efficient homes. And she brings her engineering background and hands-on design to all of it. One of the things that I'm going to wind up opening the after hours with, if you can kind of see their website, is my first question to her on the after hour will be just to talk a little bit more about all these fantastic home designs that are on our website or on the company's website. And so they can talk a little, or she can talk a little bit more about some of the ideas behind this, how it's affected the company. I was quite impressed. I spent a bit of time looking at them, and I'm excited to see the presentation tonight. Thanks.
Okay, great. Thanks for having me back. It's a great forum, and I'm thrilled to present this project. I've called it Fast, Cheap, and Net Zero Passive House. It's called the Sunflower Court Housing Project for Women and Children, and it's based in Halifax, Nova Scotia. All of us that work in this passive house world are dedicated and get a certain amount of personal fulfillment of doing our part for the planet. And for us, this project adds another layer of that, of doing our part for a really underserved population. So Add Some for Women and Children is a not-for-profit organization that shelters and houses homeless and women and children, or women and children that are coming from situations of domestic violence or other types of problems that are leaving them homeless, essentially. And so they have a lot of programming in addition to the housing, food, clothing, connections, to try to stabilize the lives for this very underserved population. So it's really a great honor to be able to work on this project. It's the team is quite inspiring. There's another not-for-profit organization called Affordable Housing Nova Scotia. They've been around since the mid-'80s, and they really advocate for these not-for-profits to help organize projects, to help them find land, get development permitting done, and help them organize funding. So they're a key partner in this project. Michael kind of introduced me already, but we're a Passive House net zero design firm in Nova Scotia. There's 10 of us. We provide custom design. We're doing a lot of affordable housing projects in the last year. We have our Passive House stock plans, and we do a lot of training and construction support as well. To date, we've worked on over 250 Passive House projects, and I'm a year behind Graham in starting, but I did the training in 2009. Did my certification in 2009. So way back in the early parts of Passive House coming to North America. Let me see if I can get my. So the project goals: 25 residential units, 4 of them requiring accessibility. You can see from the photo that the space that they currently have is pretty dark and dreary. It's actually an old school that was given to them by the city that they converted into shelter spaces. So they wanted something warm and bright. They want office space and community centers for their programming and the staff that support these families. The construction had to be very affordable from a cost perspective. They wanted to pursue the Passive House approach and achieve net zero with solar PV systems once we've reduced the energy in the building use. There's a lot of turnover in the occupancy, so durable exterior and interior finishes was also important from a design perspective. And a really interesting piece of wanting to foster security and community, with many of these clients coming from very bad domestic violence situations. The housing needed to be designed specifically to foster security. So the housing is designed around a central courtyard, and with a playground as a central point. I just got to move all these faces so I can see my PowerPoint better. There we go. The funding of the project, the land was donated by HRM. As I mentioned, it was a school built in the 50s that was decommissioned. The project was successful in applying for the federal Rapid Housing Initiative. And this was a federal program with substantial funding, which often doesn't happen. Usually you get little bits and pieces. And it had two main requirements that impacted the project. One was it required panelization or modular construction, and it required completion by March 31st, 2021. So just over a year to complete the construction. They also did a lot of fundraising for private donors and other government funding on the provincial level. And they will receive a significant rebate from Efficiency Nova Scotia, which is the organization in Nova Scotia that uses money collected from our utility bills to foster energy efficiency in the province. We've been really the project is really challenged by COVID cost increases, and we finally actually just got the last piece of announcement from the last piece of funding. They had a private donor for $972,000 today, which was what they were short to get the project started. So they just basically gave the go-ahead today to start the construction. From a design perspective, site considerations, this is just kind of a representation. There's an already cleared pad on the site, and we wanted to leave the forested area where we could. We wanted to design around the existing site grades to keep the costs down. There's already an existing driveway and parking lot that we're using. We've oriented for solar south, which is actually off to the side of the property line here. We wanted to create that privacy and security. So like there's no, all of the entry doors open into the courtyard. There's no entry doors that open off into the back of each of the buildings. And that courtyard has a playground, a community laundry, and a smoking structure. Central parking and garbage are going to be located at the back of the building, so that it's not integral to the entrances and the feeling of community in the buildings. So we want to make it cheap to build, and we started that really early in the process. So we had a really cooperative structural engineer who really gets what we're working to do. So one of the things that we did right off was reduce the frost wall, or in the States, I think you call it stem wall, from 8-inch thickness down to 6. So we reduced the concrete requirements for the walls by 25%, which also results in less embodied energy. We designed the building with bearing on the roofs front to back so that we could eliminate the bearing under the demising walls between units. And we were able to just use a ladder of steel within the slab itself, and expansion cuts without having to put another frost wall under these demising walls. Gives us less thermal bridging, again, less concrete and less cost. I don't know what everybody else is experiencing, but we're finding that the truss manufacturers, if they do the engineering on a project that says engineer the trusses for a solar system, they completely oversize the roof trusses, and that adds to the cost of the truss package. So we had our structural engineer do that sizing to avoid that tendency of the manufacturers just to oversize everything. I mentioned we designed the roof front to back and using a gable, so we're reducing siding quantities compared to using shed roofs. We are using a valley set to create this gable, perpendicular gable, and this is actually south, so the gable roof works well for our orientation for solar panels. It's designed that they're going to construct the roof structure on the ground and crane it into place to help also control the cost and make it a little faster. From an assembly perspective, it's really important that we're using locally available materials that are easy to access and familiar to the trades, to control costs and to keep things moving quickly on the construction side. Our roof assembly, very simple, just a stick frame roof trusses with blown-in cellulose. Cellulose is manufactured about 100 kilometers from the site. And we use a raised heel, of course, to prevent the thermal bridging at the corner. We're using a double stud with foam insulation in between. I call it the Sydney wall because we started using this wall in response to a project we built in Sydney where you can still buy an existing home for under $100,000. So we had to really find ways to cut costs on the construction. So the truss wall got traded in for the double stud wall. The frost wall has all the insulation on the inside, which eliminates the need for parging or metal flashing on insulation covering on the outside. And again, we engineered that wall thickness down to 6 inches. And we have a frost wall only on the perimeter of the building, as I mentioned, and not having to use these frost walls across all the demising walls. The slab is pretty simple. We have 2 layers of type 2 EPS for our value of 21. And again, we put our reinforcing in the slab rather than a thickened edge or a frost wall under the stair bearing and the demising walls. By running the roofs front to back on the frost walls and only carrying the floor loads on the demising walls, that kept the load small enough not to require anything but a ladder of structural steel in the slab. On the energy efficiency, because they are larger buildings, we can thin out the assemblies from what we see in single family homes. We use the sensitivity testing during energy modeling to really optimize the balance of our insulation levels with the cost of solar panels. And we've designed for really simple airtight details to achieve our airtightness without a whole bunch of extra site detailing. We have sharing hot water heat pumps between 2 one-bedroom units to keep the capital costs down. We've designed the windows to be installed in the weather-resistant barrier plane rather than halfway through the wall. I know there's a small energy penalty to doing so, but it allows us to install them in a method that the trades are super familiar with, and there's no extra flashing and drain sill pans required to make that work. We're using a vinyl passive house rated window from Coltec, which is also manufactured about 100 kilometers from the site. And they also stepped up with a significant upgrade to the window package, as well as a cash donation to the organization to help make this project viable from the financial side. Heat pumps were cut from the budget, and we ended up using the energy model to optimize the design to reduce cooling loads because there is no cooling in the buildings. And this, was about 25. We looked at the Minotaur, which most people I'm sure are familiar with, which is the HRV heating cooling combination unit, which are really great for small units. Their capacity works quite well for apartment size applications, but we did not, it was about 250,000 extra to implement those, so they got cut during the budget. I wanted to talk a little bit about the heating system decision. We are in a heating dominated climate. I'm just going to spin back here again for a second. Red is space heating, blue is space cooling. So you can see our energy balance is heavily weighted towards space heating. We could have made a big impact by using heat pumps here in the energy model. But the discussion was really interesting. We really didn't have the funds in the budget to use a ducted heat pump system, and often we'll use electric baseboards with a single ductless mini split. And there was a lot of discussion with the project team that the likelihood of these clients using a heat pump when they could just turn the knob on the electric baseboards was a risk. So even though the model says we could do really well with heat pumps, there was a real question whether the clients would actually use the heat pumps or just basically heat their units with the electric baseboards, losing that COP on the performance. It's possible, we know from other projects that tenants and that aren't paying the energy bills themselves can use more cooling than necessary in the summertime, leave the windows open and run the air conditioning at the same time. The occupants in these units, many of them are living on the street. So the idea of having to have ongoing training and user calls on how to operate the system with that high turnover in the occupancy was also identified as a risk in going with a more complicated to operate heating and cooling system. It was felt that the tenants would default to the simplest way to maintain comfort. These folks are not your custom home energy geeks. And so we decided to use electric baseboards, and we changed the windows to low solar heat gain glass so that we minimized the cooling requirement and know that we're going to need a few more solar panels to pay for the electric baseboards. There was also, this is a small organization that has to cover the installation cost of the equipment, but also the ongoing maintenance costs and call user questions. So electric baseboards was the decision on the heating system. And we'll see whether we will. We're considering roughing in the disconnect for electrical that a heat pump could be added in the future if the climate continues to heat up. So a few strategies to speed up the construction that really helped on our construction schedule in meeting that March 31st, 2022 deadline that was attached to the funding. The design team was extremely decisive. We went from start to final condocs in 6 months, and we started pricing in about 4.5 months. We were very fortunate that the city had buy-in to this project right from the beginning, and we had unheard of turnaround times on inquiries and permit approvals. They rezoned the lot in 2 days, which which is just unheard of for most municipalities. We have panelization, so the walls can be built while the groundwork is underway. It was, even though the design wasn't done by the builder was involved in all the design meetings and pricing options very early. So we were kept on track from a cost perspective during the design. Again, using that simple building shape and details is good for energy efficiency, but it's also good for controlling cost and the speed of construction. All locally available materials that we can buy at any building supply place. The only exception probably being the HRV. And we did use the most efficient Canadian HRV that's available on the market. We did not use a German-made HRV, again, for cost. There's one sewer, electrical, and water connections for all buildings. It's one owner. and we decided that they will be the owner for the long term with this building, so it cuts the complication for services to the building. And we had the civil engineer make some on the fly changes to the finished floor height to work around site bedrock instead of having to blast on the site. And we're involved in construction support, which we hope will help them moving quickly in implementing the passive house strategies that are part of the design. So I think the key elements in thinking about the project of what made it fast, cheap to get to passive house and net zero was there was a highly collaborative project team, really no ego in that project team. I think it's the first time there's 11 people on the design project team. I think first time ever for me that the majority were women. Of the 11, 8 were women on the project team. We found ourselves some smart structural, civil, and electrical engineers that really bought into our energy goals on the project and the cost goals as well, keeping things simple. Again, reiterating that simple building shape, more energy efficient, more cost effective, and quicker to build. Bringing our experience on affordable passive house projects to the team, I think was really valuable in limiting those design options really early on. So instead of going down the road and then realizing that this thing wouldn't meet the energy goals or wouldn't meet the cost goals, was a big help in getting the design finished quickly. We use the energy model very early on to inform our strategies and to test the sensitivity of where we should stop with our passive house strategies and invest in solar panels as a more cost-effective option. I didn't show you a site plan, but we limited the buildings to Part 9 building code. It will mean something to Canadians, but for our other world friends, there is 2 major building codes in Canada. One applies to commercial and applies to residential, and the requirements are much more stringent, like sprinklers, a bunch of more fire regulations and so forth that apply to commercial. So we broke the 37,000 square feet into 6,000 square foot buildings that will allow us to stay in part 9 of the building code. We're using panelization, as I mentioned, and locally available materials and equipment. So that is the end of my presentation. I have no idea how I did on time tonight, but there you have it. And I will leave it there for questions.
That was that was fantastic. Thanks. It was as good as I was hoping it would be. Sean, take it away with questions.
All right, we got a few lined up, so this is great, Natalie. We're going to start with Enrique.
Thank you, Sean. My question is, you're using a double stud wall there, and it seems that the 2x6 exterior wall is the load-bearing wall.
Yes, that is correct.
Okay, and is that braced with plywood or how do you?
That's a great question. It's actually braced with the metal T-channel wind bracing, which provides the shear strength necessary in the walls. With the cost of, like, when I first started building, we were paying $6 a sheet of OSB, and now we're paying about $57 a sheet in our market. So we eliminated sheathing in the wall.
Oh, that's great. Yeah, the reason I'm asking is because I'm working on a project here, and it's also a double stud wall, and Fuse doesn't like to have the load-bearing wall on the outside because of rotting of the sheathing of the OSB or the plywood.
Yeah.
And it's just filled with cellulose, but you seem to have also a kind of a foam in between or something, or?
Yeah, we have a layer of ES foil face non-perforated foam in between, and we use that for both our vapor control layer and our airtight layer.
Natalie, do you mind bringing up that slide? Just I've got a couple of people that wanted to
Yeah,
look at
sure.
it again
let me-
while you're going through it. So
let me see
that'll
if
be
I
great to
can
help.
do that.
And I know Ian's got a couple questions too about the wall, so might as
Okay.
well fire it up. Thanks.
Yeah, that's probably as good a one as any.
Could you enlarge it, please?
I don't think I can.
Or put it in presenter mode or something?
I have it full screen on my.
Oh, I see.
Yeah, you
Okay.
need to just swap displays because we're seeing your
Are you
notes.
seeing this? Are you
Yeah,
seeing
but we're
this?
seeing your notes and all the
Ah.
other slides there.
Okay.
On the top, it says swap displays. It should work.
Okay. Thank you. Sorry about that.
Okay,
go.
that's the right
Great.
one. Yeah.
Apologies.
Thank
Yeah, there is.
doesn't the foam board in between the cellulose, doesn't it impair the cellulose drying or thermal hydrothermal process in there?
Yeah, and we were really fortunate. We got some funding from NRC, which is the National Research Council, to do some building science studies on assemblies. So we spent a lot of time woofing a variety of assemblies in 6 different climates in Canada. And the thing I will, through that, and what was really interesting, like a wall that works perfectly in Edmonton, Alberta, fails in St. John's, Newfoundland, and vice versa. So, you know, my first point about wall types is they need to work in your specific climate, and caution you against, you know, sort of just moving different assemblies across climates without really checking it. So your question about drawing and that there's sort of this, I don't know, I guess for me, building science, my building science rule of thumb is what is in these thick walls, we always have multiple vapor control layers. And what I usually talk about is what is the strongest vapor control layer, and making sure you've got drawing in both directions. So the foil faced foam is a stronger vapor control layer than the plywood on the outside. And we are using plywood rather than OSB with the assumption that it's more vapor open when it's wet. So if there is moisture, there's more chance for drying. And we don't have a supply of fiberboard here in our market. We cannot get fiberboard. And the other thing is this building has vinyl siding on it and you can't nail to fiberboard. So it's not a nailing base. So we have plywood on the outside, foil, which is the strongest vapor control on the inside, and then drywall with paint on the interior. So the idea of drawing to both sides of the foam layer.
Thank you. Great.
Thanks. We'll just leave that slide up because I know there's come more. James, go ahead with your question. So it's James, iPad number 2. You're up next. Oh, I don't see James. So Ian, let's go over to you because I know you had a couple of questions and you want to dive into the wall here too. So
my question was mainly why, since it's a 2-story building, did you need the 2x6s? Was it just for the overall thickness? Because one would have thought that 2x4 would structurally be enough.
Yeah, we need more insulation to the exterior than we need to the interior. So it's a 2x6.
Okay, so it's purely as a spacer bar, effectively.
Exactly.
Okay. I think that was the. Oh yeah. Did you look at doing permanent wood foundation or anything instead of getting rid of the concrete?
I totally hear you from an embodied carbon perspective, and it's very far from mainstream construction here. There's no wood. There's no wood you never see a wood foundation here. So we really try to stick with mainstream construction methods wherever possible.
Yeah, could be a wash on material cost, but if labor cost is higher because of it, then it totally wouldn't. So yeah.
This is James. Does anybody hear me?
Yes, we can.
Yes, James, we can hear you now.
Oh, yeah. There's this Mr. Cool heat pump, and they come out with a ductable system. Anybody have any experience on that?
I don't, I've never come across them. Maybe someone else has.
James, you're coming in and out, so why don't we hold on Mr. Cool and we can maybe carry that conversation after we get through this list here, but sounds intriguing. Ian, we'll just come back to you. So, sorry, were you happy with the question, with the answer? I know you keep trying about different technology, so I appreciate you asking.
No, I'm just curious to see what people have looked at to reduce costs and stuff like that. And I haven't seen too many people looking down that route as a cost-saving one. So it's just interesting to get more data points if anyone has them.
No, great. Okay, thanks, Natalie, and thanks, Ian. We'll go over to we got Graham and then Kevin. So Graham.
My question, I think I answered the second one. My first question was, how does the modeled energy use of this project compare with passive house standards?
Yeah, well, we typically work with the FIAS standards, Graham. We were part of the original pilot to move away from the one shoe fits all because we had a duplex affordable housing project that south was in the backyard, which all sounds really good. But it backed onto a school that was completely shaded, and we just could not make that project meet the targets. This project I think will miss on primary energy without solar panels, but because they're moving to net zero, they will be okay, in that balance. But because of the larger building, it's really pretty easy to hit the heating and cooling targets and the air tightness on larger buildings with the strategy that we're really comfortable with. So, but we wouldn't hit the primary energy target for sure, especially without a heat pump on the heating and cooling.
Sean, can I ask my second question real quickly?
You can, only because I'm going to follow up some fun trivia between you two. So go ahead.
The concrete. That concrete notch out, that's for thermal bridging, I guess?
It is. Like, we did a bunch of therm right on that bottom plate of the inside wall, and it's too cold without it.
So again, for those that didn't catch that, see the little detail? Again, Lloyd called us. Yeah, we're nerding out on the wall today. It's good stuff. So one of the things I love about breakout rooms is just you find out things about people. And Natalie, do you want to share how well you know Graham and how close you guys came to being best friends?
Yeah, well, I got to know Graham quite well at Passive House conferences over the year, and we put together, we just sort of put together the fact that we actually grew up about 2.5 blocks from each other in the small town of Sydney, Nova Scotia. But I'm a lot older than Graham, so we didn't actually go to school together.
I'm really touched you named a wall assembly after the place.
Right?
It's a small world. Sometimes we all connect to, ports either in Halifax or New York or Boston. So good stuff. All right. Okay. Moving on. Kevin Brown, it is your turn to ask your question.
And I can't remember what my question is like. That's what I get for typing, paying too much attention for the chat.
Well, it's funny because it was tough because you wrote base or top question mark, and I was like, well, I don't know what it is, so you're gonna have to figure it out for me.
Okay, there you go. It's referring to Graham's question actually, and that is a spot that we found to be a bit of a problem. But here in Alberta, we most often bury your slabs. So people go, well, if I'm going to dig a 4-foot frost wall, why not dig an 8-foot? Why not give myself a basement? But still, what we're finding is the slab to foundation wall connection is a lot more easily handled with extra foam along the side. So similar detail buried deeper, same results. And so that's really interesting. Thanks for that, Natalie.
Yeah, and on this project, we have wheelchair accessibility. So that slab needs to be a top of frost wall, or else we've got a weird detail of trying to step down into the frost wall to the slab. Yeah, top of frost wall is top of slab for accessibility.
Yeah. Hey, Natalie, in Nova Scotia, are many people installing basements? Are people not bothering? I guess it depends on where you live and how
really
high the water table is.
Like our climate is really tricky here. Like we get so many freeze thaw cycles, and in the spring the ground's still frozen, and then it pours rain, and I don't care how well you build a basement, it will leak eventually. And in our climate, you almost always have to run a dehumidification in it. So we very rarely build a basement unless it's a walkout. In our practice, you still see them for sure, but they're just not great living space. So we really encourage folks to move away from them. And we have an aging population here that is downsizing and looking for energy security and doing right by the planet. And many folks are now interested in aging in place and accessibility. So the basement kind of goes out the door with those as well.
Yeah, just a quick follow-up. Do you find that slab on grade is useful too, or is a frost wall much preferred?
We do a lot of engineered slab on grades. It depends on the site. And this site had a massive amount of infill in it to flatten it out for the school. So it would have been a lot more geotechnical engineering to engineer a slab on grade. A slab on grade definitely uses less concrete. It's quicker. There's all kinds of advantages, but it wasn't very viable on this project.
Kevin, I think that sums up all the answers that you needed, correct?
Yep, no worries. Thanks a lot.
Perfect.
That's great.
And Patricia had asked the same question, and we've now answered that detail. So I think Patricia is good. Patricia's audio is not working. So if you want to just give me a note, Patricia, or a thumbs up, we will keep moving on. We'll head over to Zach now to give sponsors. Zach?
Great. Yeah, and I've got some announcements as well for what's coming up next week. So it's a busy week. So first off, everything we do at the accelerator, and also I would argue as practitioners it depends on manufacturers who are doing innovative work, right? And these manufacturers are ones that are really mission aligned with the accelerator and are supporting what we do. And we wouldn't be able to do these happy hours or construction tech or our podcast without their help. So I want to give them a big thank you. Our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thank you also to our patron sponsors, who are Aero Barrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Innotech Windows and Doors, Sanderson Sustainable Design, and US Engineered Wood T-Stud.